Hello everyone. Today we'll learn about DFT, discrete Fourier transform. The DFT is one of the most powerful tools in digital signal processing, which enables us to find the spectrum of a finite duration signal. And in mathematics, the discrete Fourier transform converts a finite sequence of equally spaced samples of a function into a same length sequence of equally spaced samples of the discrete time Fourier transform DTFT, which is a complex valued function of frequency. An inverse DFT is a Fourier series using the DTFT samples as coefficients of complex sinusoids at the corresponding DTFT frequencies. It has the same sample values as the original input sequence. The DFT is therefore said to be a frequency domain representation of the original input sequence. Application of DFT. The DFT is the most important discrete transform used to perform Fourier analysis in many practical applications. The DFT is also used to efficiently solve partial differential equations and to perform other operations such as convolutions or multiplying large integers. Since it deals with a finite amount of data, it can be implemented in computers by numerical algorithms or even dedicated hardware. Here is the illustration of DFT. The formula. The discrete Fourier transform transforms a sequence of n complex numbers. Here we can see these n complex numbers. So when we evaluate the small n, it will be evaluated 0 to n minus 1. So after decomposing the exponential, we can find this sinusoidal component. Okay. Now, the next example. In this example, we can see that here is n equals to 4. So actually, as in this equation, we can see that it will summation of n equals to 0 to n minus 1 actually. So n minus 1. So here n equals to 4. So we can say here n equals to 4. So we will write it later. First of all, we will write the formula actually. After writing the formula, we will write the value of n. We will replace the n by 4, okay? As there is given that n equals to 4, n into kn. Now we will replace the n by 4, okay? Where will be the n? This n and this n will be 4. 4, okay? Now, what will we do? We can see here that we have done that we just evaluated xk here. So we will get 4x here actually. So we'll get x0, x0 we can say, x0, x1, x2 and x3, okay? We'll get these 4 components. You can see it from, okay, we can replace it by 3, okay? 4 minus 1 equals to 3. So n equals to 0 to 3. So 0, 1, 2, 3, we will get these 4 components. So we have right here the equation for these 4 components. So these four components will result this. Okay. After calculating these equations, we have got these values. So inverse DFT, the discrete Fourier transform is an invertible linear transformation. The inverse transform is given by xn equals to 1 by n summation of xk into I to the power I e to the power I twice pi kn divided by n. Okay, this is the inverse transform. So here we come to the FFT. What is FFT? FFT is fast Fourier transform. It's an algorithm that computes the discrete Fourier transform of a sequence or its inverse. It manages to reduce the complexity of computing the DFT. It increases the speed of the algorithm. The difference in speed can be enormous, especially for long data sets where n may be in thousands or millions. In the presence of round of errors, many FFT algorithms are much more accurate than evaluating the DFT definition directly or indirectly. The application of FFT: fast, large integer and polynomial multiplication, efficient matrix vector multiplication for Toeplitz, circulant and other structured matrices. Filtering algorithms. See overlap, add, and overlap save methods. If you see the overlap, add, and overlap save method, you can see that filtering algorithms will use FFT, that means fast Fourier transform. First algorithms more for discrete cosine or sine transforms. Example, fast DCT used for JPEG and MPEG or MP3 encoding and decoding. Fast Chebyshev approximation, solving difference equations, computation of isotropic distributions. Okay, thank you. So that's all for today.